For this function cubic, where the x minus 2 is a factor of fx, so since this is a factor of fx, I would like to use a long division, taking this function divided by x minus 2, and I hope to get another quadratic factor. Then later on, I hope that I can factorize the quadratic factor and hence get the other uh, roots, so that we can sketch the graph and then find the domain and the range. So using this function divided by the factor x minus 2, now we focus on the leading term. Leading term divided by the leading term in the divisor, we got the 3x cubed divided by x, we have a 3x squared. 3x squared multiplied by x, you get 3x cubed. All right, and then 3x squared multiplied by 2, you get a negative 6x squared. And now you can start to minus using the function minus 3x cubed minus 6x squared. You got 0 over here. And 4x squared minus a positive 6x squared, you have a 10x squared. Minus 17x, take this down, bring this down. All right, you got this. And then now we focus on the leading term over here. 10x squared divided by x, you have a positive 10x. Positive 10x multiplied by x, you have a 10x squared. 10x multiplied by negative 2, you got a negative 20x. Now subtract this expression with the expression down here. 10x squared minus 10x squared, you got 0. Negative 17x minus negative 20x, you get a negative 17x plus 20x, that you will have a positive 3x. And bring down the negative 6, you got the 3x minus 6. Now again, leading term divided by the divisor. So you have a 3x divided by x, we have a positive 3. Positive 3 multiplied by x, you have a 3x. Then 3 multiplied by negative 2, you got negative 6. So there is no remainder because this is the factor. Meaning that our fx, it can be written as an x minus 2 multiplied by our quadratic factor, that is a 3x squared plus 10x plus 3. And now I'm going to try to factorize this. Hopefully that this can be factorized into is a linear factor. Okay, so you have a 3x multiplied by x, 3, 1, and a positive, positive. Try to expand it back. Yeah. Then this is your fx. So to sketch this function, I'm going to start my first step, that is getting the root. Okay, obtain the root, you will let the fx equals to 0. Taking this function, which is in the factorized form, you have your x minus 2 multiplied by 3x plus 1, x plus 3, and equate this to 0. You got your root x equals to 2, x equals to negative 1 over 3, and x equals to negative 3. So now you can start to plot these three values on your graph. Get ready your x's, and then you plot the x equals to 2. This is 2. Okay, plot the point. And x equals to negative 1 over 3. This is negative 1. Negative 1 over 3 will be roughly here. This is a negative 1 over 3. And x equals to 3. This will be negative 1, negative 2, negative 3. Meaning that your graph will passes through these 3 points. And now you don't know the shape, right? You need to determine the shape by considering the value of the a. So the a, when you expand it back, okay, when you expand this back, you scroll back to the question, you can see that your a, which is your coefficient of the x cube, is 3, right? So this your a is a positive, where your shape of the graph will be not going up, down, up, up, down, up. Okay, so up, down, up, meaning that your graph will passes through the negative 3 and reaching a local maximum, it will go down and continue going down and then reaching the local minimum and go up. Okay, so this is your graph. And you can see that your graph passes through one point at the y-axis. This is your y-intercept. You can get your y-intercept by putting your x at 0. You putting 0 over here, 0, 0, meaning that your y will be negative 6. Here, this point will be negative 6. Okay, so this is your y equals to fx. From here, you can get your domain. Your domain again is from negative infinity up to infinity. Okay, and the range is from the negative infinity up to infinity. Because this question did not state the domain, the restriction of the domain. So our domain and the range both will be negative infinity to infinity, or we can say all the real number. For this function, I'm going to find the other roots, the other factor by using the comparing the coefficient method. So the fx, it can be written as a x minus 3. That is the first factor given by the question, and multiply by a quadratic factor, which I represented with the ax squared plus bx plus c. Expand this. After I have expanded, I got this, and I will collect all the like terms together, factor out the x squared, and we have the coefficient b minus 3a, and also the same for the x. Factor out the x, and you have a coefficient c minus 3b. Now we can just compare this expression with the expression given by the question, which is our function cubic. Okay, then I will compare the coefficient of the x cube, which I have a here, the coefficient, and the function given is negative 8. So the a will be equal to negative 8. And after that, I compare the coefficient of the x squared. Here I have a b minus 3a. That is my coefficient of the x squared. And function given is 59. So putting your a as a negative 8 into this equation, in order to solve for the b, you have your b equals to 35. Okay, and in order to get the value of c, I will compare the constant. The constant here is a negative 3c, and in the function given, the constant is 99. So my c will be equals to negative 33. Okay, so now you got your ABC, right? Your function can be written as x minus 3, and a is your negative 8x squared plus b is your 35x minus 33. Okay, because your factor is x minus 3, and your fx can be written as a linear factor multiplied by a quadratic factor, where your quadratic factor is given by this. Okay, then we can actually factor out the negative first. Factor out the negative over here, you got a 8x squared minus 35x plus 33. And now we're trying to factorize the quadratic factor. After factorize, we have this. And in order to sketch the graph, first step, I will get the roots first. Let the fx equals to 0. And you can see that my function will be equals to 0. Now I can get my roots first, so that I can sketch this. I can plot this point on my graph. This means that, yes, you can write your function as a negative x minus 3 square 8x minus 11. Okay, then actually we got the two roots. One is x equals to 3. The other one is x equals to 11 over 8. 11 over 8 roughly will be 1.4. So we will plot at 1. This is a 1 unit. Okay, 2, 1.4 maybe roughly will be here. So I plot my point here. That is my 11 over 8. And the 3 will be here. Okay, so the graph will pass through these 2 points. Now we need to get the shape of the graph. The shape, we will consider the value of the a. Consider the value of the a. You have your a is a negative 8, right? So it's a negative number, meaning that your shape of the graph will be down, up, down, down, up, down. So the shape of the graph will be in this form. But there are two cases that will satisfy these two conditions. First condition is passes through these 2 points, which I highlighted here. And second condition is having this shape. There are two cases that can satisfy these two conditions. Now I'm going to show you how these two cases might happen. Now you got the shape like this, right? Okay, first case, it might be touching the 11 over 8 and go up, go down again, cuts through the x equals to 3. Or the second case might cut through the 11 over 8 and then going up again, touching the 3 and then go down. All right, so you must make sure which case is actually happen. So what is the difference between these two graph is the shape of the graph between the 11 over 8 and 3. So now it's very simple. We just substitute a value, maybe 2. 2 is between them. We can substitute 2 into our function so that we can see that when x equals to 2, the y value is either positive or negative. If it takes a positive value, meaning that the case A will happen. All right. If you substitute 2 into your function, you got the negative value of y, meaning that the case B will happen. Let's see which will happen. After I have checked, I got the value f2 equals to negative 5, meaning that when the x equals to 2, the y is equals to negative 5. So case B is actually happen. Okay, so we will sketch the graph in this form, that is going down, cuts the 11 over 3, and then going up again, touching the 3, and then go down again. So here is our graph. It cuts the 11 over 8, okay, and then go up, touching the 3, and then go down like this. Okay, so here will be the y-intercept. You need to find by putting the x in as a 0. Okay, then you can get your y value, that is your y-intercept. Okay, I got this 99. Putting the 0 into the x, I get this 99. So these two having the arrowhead to shows that equals to infinity and negative infinity. So my domain again and my range will be from negative infinity to positive infinity, the same as the range. All right. For this function, x equals to negative 2 is the root of the f(x), so the factor is x plus 2. From the root, we can derive we can get the factor. The first factor given is x plus 2. So I'm taking this function using the long division divided by x plus 2, hoping to get another quadratic factor. So since the x squared term is not appear here, but in the long division, I'll still will create a term with the x squared with the coefficient of 0 so that I can easily divide. So again, we will focus on the leading term. For x cubed divided by x, I got 4x squared. 4x squared multiplied by x, you got 4x cubed, and plus 8x squared. So 0x squared minus 8x squared, you got a negative 8x squared. Bring down the negative 15x and bring down the 2 as well. Now we focus on the first term also. Okay, the leading term divided by the x, I have my negative 8x. So that negative 8x multiplied by x, I got negative 8x squared. Negative 8x multiplied by 2, you got a negative 16x. Minus again. Then negative 15x minus negative 16x, it will become positive 16x. So it will become x plus 2. Bring down the 2. Okay, so divide. When the x divided by x, you got 1. You got x minus x plus 2. Okay, so now your function can be written as the divisor, which is your x plus 2, multiplied by the your quadratic factor, that will be 4x squared minus 8x plus 1. Okay, now, so we try to factorize the quadratic factor. Since this cannot be factorized, just forget about the factorization. I will try to find the roots in order to sketch the graph, right? Okay, we need to find the roots. To find the root, I will let my function equals to 0. Now I'm trying to solve for this equation. Okay, so to solve for this equation, first root, I got my x equals to negative 2. Another root, I need to solve the equation, the quadratic equation. And this quadratic equation cannot be factorized. I need to use a formula or your calculator. So you will get your root as I use the formula of quadratic to solve this equation. I got the x equals to 1.8660 and 0.1340. So now you got three roots. This is your first root, second root, and third root. You need to plot this value on your x. So this is your first point, your first root, x equals to -2. And the second root will be the okay, I will plot the 1.8660 roughly will be somewhere here. Okay, so this is your 1.8660 and the third root will be 0.1340 is very close to origin. Okay, I just label this as a 0.1340. So now the graph will passes through this 3 point. And we need to know the shape of the graph. To know the shape of the graph, I will consider back the value of the a. Since the coefficient of the x cube equals to 4, so I would say that the a is greater than 0. Okay, the a is greater than 0. Then I would say the graph having the shape like this, up, down, up, up, down, up. Okay, so again, it might be two cases. Sorry, yeah, you got three roots, right? So the graph will be just up, down, up like that. Okay, the graph will passes through the -2 and reaching a local maximum. It will go down and go up again. Okay, so the domain again is all the real number and the range the same, yeah, all the real number. And there's one important point in the graph that you might need to know its value. That is your y-intercept. So substitute the x equals to 0, putting the 0 into the function, 0 here and 0, and this is 0. You got 2 multiplied by 1. So the y-intercept will be 2. Okay. Now we can label this as your y equals to fx and get the domain and range. For this function, again, use the same method. I'll use a long division, divide by a 4x minus 3 so that I can get the other quadratic factor, meaning that now you can see that this function don't have the quadratic vector, don't have the term of x. So our fx, it can be written as a 4x minus 3 multiplied by 25 minus 4x squared. And actually this can be factorized in the very easy method. That is, this can be written as a 5 plus 2x, 5 minus 2x. Okay, so to sketch the graph of the function, again, we will let the fx equals to 0, meaning that the function equate to 0. Solve the equation. I have my x equals to 3 over 4 and x equals to -5 over 2 and x equals to 5 over 2. So total we have 3 roots. You can start to sketch this these roots on your 3 over 4 is a 0.5. It will be roughly here. Sorry, 0.75. -5 over 2 will be -2.5. 2.5 will be here, and 2.5, this is 2, right? So 2.5 will be somewhere here. So this is the point, -2.5. This is a 2.5. So now we're going to sketch a graph which is passes through these 3 points by considering the coefficient of the s cube, that is your a. If your a is negative, means that your shape of the graph will be a down, up, down. Okay, so now I'm going to sketch this shape on my axis, which is going down, passes through 2.5, and then reaching a local minimum, going up again, reaching a maximum, local maximum, and going down again, passes through the 2.5. Okay, so you have your graph like this, and we need to find this value, that is your y-intercept, by substituting the y equals to 0, putting the x equals to 0. You can put your x as a 0 here. Okay, so you will have you got a -75. So this value is actually -75, which is okay because now we are sketching the graph, though it's not really making sense, because the the uh, the the length that we use is too short. It's okay because the scale of the y and scale of the x can be different, no problem. Okay. And we can now label this as a y equals to fx. Again, for any cubic function, if the function did not state any special condition on the domain and range still will be from negative infinity up to infinity. All right, this is the last example of this of my video of discussion in a cubic function. All right, thank you for watching.